So, you're a project manager and you're gearing up for your CPMI certification. You know you've got to get a handle on machine learning. But here's the thing, you don't need to be a data scientist. This right here, this is your guide to the core ML concepts, all from a PM's point of view. Let's jump in. And you can be confident in what we're about to cover because it comes straight from the source, the PMI CPMAI committee itself. This means everything is authoritative, it's directly relevant, and it is 100% aligned with what you need to know for the exam. This is the official stuff, just broken down for us project managers. And let's be super clear about one thing. We are not going to be writing any code here. This is not about Python or debating the finer points of algorithms. This is your project management playbook. We're here to understand the why and the when behind it all, so you can lead your AI projects with confidence and actually deliver business value.
All right, so let's dive right in. At the heart of it all, there are really only 3 fundamental ways that machines learn. You can think of these as the main strategies your technical team is going to choose from. Pretty much every AI project is going to start with one of these 3.
First up is supervised learning, and it's probably the one you'll run into most often. The magic ingredient here is something called labeled data. It's like we're giving the algorithm a study guide with both the questions and the correct answers. The whole goal is for it to learn the patterns so well that it can start answering new questions it's never seen before, all on its own. Now, supervised learning is a powerhouse for 2 main types of problems. You've got classification, which is all about putting things into buckets. Is this email spam or not spam? Is this transaction fraud or legit? Then you have regression, which is about predicting a specific number on a scale, like the exact price of a house or what the temperature will be tomorrow. Okay, but what happens when you don't have all the answers up front? Well, that's where unsupervised learning shines. For this one, we give the algorithm a whole mess of unlabeled data and basically tell it, go figure it out. There's no teacher, there's no answer key. The machine has to explore the data and find hidden patterns all by itself. And this is where things get really cool, because it's all about discovery. Take clustering, for example. It can automatically find new customer groups you never knew existed. Or anomaly detection, which is great for flagging a weird transaction that just doesn't look like anything else. It's all about uncovering insights you weren't even looking for. And our third method, reinforcement learning, well, that's a whole different beast. This isn't about learning from some spreadsheet of data. Instead, we have what's called an agent. Think of a robot or a game-playing AI, and it learns by doing. It tries things out in an environment and gets feedback, either rewards for good moves or punishments for bad ones. It's all about learning through trial and error, right? The agent is in this constant dance, balancing exploration, trying new things to see what happens, with exploitation, sticking with what it already knows works. It's this dynamic learn-as-you-go process that makes it so powerful for really complex stuff, like self-driving cars or mastering a game. Okay, so let's put it all together real quick. Supervised learning, you've got labeled data, and you're predicting something you already know. Unsupervised, you've got unlabeled data, and you're discovering hidden patterns. Reinforcement, you're learning the best moves through trial and error. As a PM, just knowing these 3 apart is your first huge step toward framing the business problem correctly. Now, once your team picks a lane, supervised, unsupervised, whatever, they're gonna run smack into one of the biggest, most common hurdles in any machine learning project, the overfitting problem. This is something that you, as an AI project manager, absolutely have to understand. I know, it sounds totally backward, right? How could learning something too well possibly be a problem? But believe me, in the world of machine learning, this is a major, major reason why projects fail to deliver. So here's what overfitting is. It's when your model doesn't just learn the important stuff in your data. It starts memorizing all the random noise and tiny irrelevant details too. The student analogy here is perfect. Think of someone who just memorizes the answers for the practice test. They'll ace it, but give them a slightly different problem, and they're completely lost because they never actually learned the concepts. And this chart just lays it all out, plain and simple. Look at that overfitted model. It looks incredible on the training data, maybe gets a perfect score. But then you unleash it on new, real-world data, and its performance just tanks. A good, solid model might not be perfect in training, but it holds up when it matters, out in the real world. And that's what delivers business value. So how do we fight this? How do we stop the model from memorizing? Well, the main weapon in the arsenal is called regularization. The simplest way to think about it is that we're adding some rules that penalize the model for getting too complex. We're basically forcing it to ignore the noise and just focus on the big, general patterns that really matter.
Okay, so we've got a way to prevent our model from going off the rails, but how do we get it to perform at its absolute peak? That brings us to another key activity, tuning. This is all about dialing in the learning process itself.
You see, every single machine learning algorithm has these settings that you have to configure before you even start training. They're called hyperparameters, and the analogy from the study guide is perfect. They are literally the dials and knobs on the algorithm. A data scientist turns these knobs to control things like how complex the model can get or how fast it should learn.
So, how do you find that perfect combination of settings? Well, it's a whole process. You could have an expert do it manually, just based on experience, or you could use something called grid search, which tries every single combination. That's super thorough, but it can be incredibly slow and expensive. That's why teams often use smarter, more efficient methods like random search or Bayesian optimization. As the manager, you just need to know that there's a trade-off here between time, cost, and getting that perfect result.
Okay, we've covered a lot of ground. The learning types, overfitting, tuning, but here is the most important part. How does all of this technical stuff connect back to the CPMAI framework that you need to know for the exam? This is where we bring it all home. Let's connect the dots. The learning paradigms, supervised versus unsupervised, that's a foundational decision you make when you're framing the business problem way back in phase 1. What about hyperparameter tuning? That's not just a technical task, it's a critical activity you need to plan for in phase 3. And overfitting, that's a massive risk that you have to actively manage during development in phase 4 and then evaluate for in phase 5, using techniques like regularization to make sure your model is solid.
And this is so crucial to remember. Your goal isn't to be the one turning the knobs and dials. Your role is to understand why these things are being done, to ask the smart questions about the trade-offs, and to oversee the whole process to make sure that the final model actually works, is trustworthy, and solves the real business problem we started with.
And there you have it. Those are the key ML concepts that bridge the technical work and your project management framework. You now have the language to have those critical conversations with your team and your stakeholders. So the only question left is, are you ready to start asking the right questions on your next AI project?